Hi and welcome to this video about a simple RPC client and server. What I want to do in this video is to demonstrate the simplest RPC server and client I can master. So first, what is RPC anyway? Remote procedure calls is a very well-known and old mechanism whose idea is to simply allow us to run a function or execute a function remotely as easy as it is to execute a function locally, with some infrastructure taking care of all the details there. So the Microsoft RPC implementation has several built-in communication mechanisms, such as local using ALPC or advanced local procedure calls, using TCP and using name pipes as probably the more common options. In fact, RPC, even if you don't use it directly, it is used behind the scenes when using COM. So COM is built around many of the concepts of RPC, extending them to be object-based. So in this video, we're going to look at the classic, the core RPC mechanism, so to speak. Okay, so in order to do this, I'm going to create a new project. We're going to create two projects. We'll start with a server and then add a client. So I'm going to create a simple console application without any special adjustment to it. We just put it into some better directory. Let's call it simply server. And the solution is going to be called simple RPC. Okay, so the first thing we need to do is to define an interface. So the idea here is that an interface is just a bunch of functions we'd like to expose using RPC. And so just like in the world of COM, if you may be familiar with that, in order to define an interface, we need to use a file with the extension IDL, that is an IDL file, an interface definition language file. So let's add that. So let's look for IDL. Let's go ahead and give it a name, something like a calculator IDL. It's a very, very simple thing. Now you might be wondering, why do you need an IDL in the first place? I mean, can't we just define the functions that we need in some C or C++ file? And so the thing is, if you're familiar with COM, you probably know the answer to that. But here's the thing. Suppose you have a function like this that accepts an integer pointer, something like this. So when you look at this function from a C++ perspective or C perspective, we see here a pointer to an integer. But in fact, this pointer p could point to one integer or 100 integer or 1,000 integers. In fact, it could be an integer that's been returned from the function rather than being given to the function. So the direction here matters. For normal C++, we don't care, but for remoting, we have to care, because the infrastructure will create a proxy or a stub, well, technically a stub and a stub as it's called in RPC, which will facilitate the communication and passing of parameters from client to server and back. So we have to be more specific than that, and C and C++ don't allow us to do that. This is where IDL comes in. So the first thing we see here in the IDL is some imports that are typically useful for COM stuff. We're going to remove them. What we want is to create an interface, and this is going to be an RPC interface rather than a COM interface. Let's call that something like calculator. And we need to provide here the methods, really the functions. These are all C-style functions that we want to expose by exposing this interface. So I'm going to do the simplest thing possible here. Sorry for being so unimaginative here. We're going to have something that's going to add up two numbers. So here's where the IDL magic comes in. You can see here that we have these kind of attributes like in, indicating the direction of the parameter rather than having something like out. We could of course use something like out as well, like so, maybe getting the result back using an output parameter, definitely possible to do. And it's also possible to specify sizes and things like that, but we'll keep it simple here and just return the result as a returned value from this function. Now every interface must have a GUI to represent it uniquely. So we're going to open up the GUI generator, one of the tools that you get with Visual Studio. It looks like this. We're going to select the registry format, which is the closest one that we need. Use the copy button here and then use the UID of attribute to paste it in. Just going to remove the curly braces. And we're done with that identification for this interface, and this interface is technically done. So if I go ahead and build that, it should build successfully. And it's not perhaps clear by now exactly what has been built. I mean, what is happening with this IDL file. So as it happens, it's going to be processed by something called the middle compiler, the Microsoft Interface Definition Language compiler, that's going to generate some files out of this like definitions. These are just, well, really more like declarations, just saying something, but there's nothing to back it up just yet. Okay, fine. So now we're going to go back to our server and we want to expose these functionalities somehow. So obviously we need the add function. Let's go ahead and implement an add function. You know what? Let's not implement that just yet. First, we need to go ahead and do some stuff like make this actual server. So we need to listen to some connections. We're going to use some RPC API, like RPC server use prot seek and endpoint. So basically it's trying to create or to build an endpoint out of a bunch of parameters. If you look at the parameters here, there's a few things that are needed. One of them is a string for the protocol to use. So which kind of protocol do you want to use? Do you want to use named pipes or TCP ports, or maybe just doing things locally? So I'm going to stick with locally for now because it's easier to show in some tools, but feel free to change that later on. It's perfectly fine. And then we have to provide some value for maximum calls. One is going to be good enough. It doesn't mean that you can only have one call. It just means you're going to accept one call at a time, which is good enough for our purposes. Then we have to provide an endpoint. An endpoint is the unique name for the endpoint for this particular server. And so based on the actual protocol, we need to specify the correct format. So for ncal RPC, that is the local RPC, we need to provide a colon and then in square brackets some name. Let's call that calc. It just needs to be the same on the client side so they both can properly communicate. We can of course put it in some common file, but I'm going to skip that. And the last parameter is security descriptor, which we don't need here, just going to specify null. And what we get back is some kind of status. This is just a value where 0 means success and anything else means some kind of error. So we can use an assert here, for example, to verify things work as expected. I'm not going to do any big error handling here to save time. For that, we need to add include for assert. You can see that in fact that's not enough. There seems to be some errors there, and that's because this thing requires actually something called RPC WSTR, which is defined to be something close to a wide character type pointer, unless if we add a particular defined here, it will actually be that RPC use native W character. But still, this is supposed to be a read-write kind of buffer. We won't have a read-only buffer here, so I'm going to forcefully cast it and not bother creating local variables on the stack. It will be just fine because these variables are typically just read. So once we have that going for us, we need to register the interface. Well, what about that interface anyway? We wrote an interface in some IDL file, but where is that going to actually end up? So one of the things that we get is in fact a few files being generated. If we look at the IDL file, go to its properties, we can see that there's a middle tool that's going to be processing that file. Some information here. For example, the header file that's going to be generated, that's a C header file that we can actually use in C and C++ code, has this name pattern, the file name _h.h. We of course can change that, but we'll stick with it. Why not? It seems to be fine, which means we can go ahead and include this thing. So there must be something called calculator _h.h. Indeed there is, and you can even press F12 and go into that file, and you notice it says it's an always generated file because it has been generated by the middle compiler. There's lots of stuff here apparently, but at least one thing that we're looking for here is some kind of server handle representing the connection. So there's some kind of variable here. We're going to use it in our next call. So let's go ahead and do the next call. That's going to be RPC server. We need to register the interface. So there's this function here, and I'm just showing a very small set of functions that are actually available. That's going to be good enough for our purposes. So here's the specification here, so to speak. It's the some handle that's being created by the code behind the scenes that's going to represent the interface, so we can connect, register it, and then connect to it. We don't need the actual GUID here because we just have one interface. That's going to be good enough. And then there's another parameter which is not really interesting. Specify null here. And again, let's make sure that this works. The last piece in the server is to actually start listening. Once we register the interface, we can start listening in the server right here, this main function. So the server listen here. We can use one, here's the minimum number of threads. That's good enough. The maximum calls, we can use a constant call listen max calls default, and we don't want to wait. We actually want to wait until we get a call. So we don't want this function to ever return. Normally, just wait for connections, execute those functions that are being requested, and continue waiting for more clients. Before we do that, we can even add a little printf here saying that the server PID happens to be this one. It would be easier to find in various tools. So once we have that, let's go ahead and add stdio. Let's try to compile this thing. We can use return 0 here just for completeness. Let's try to compile this. So notice that it compiles, but it fails to link. And the few things that are missing, we can see there is some RPC functions that are not really provided by any of the normal import libraries. In fact, we have to add them. So that could be a pragma. Let's add that using a source file. So we need RPC runtime for.lib. This is the import library. Once we do that, we still get one external symbol, which is something about this calculator symbol. So this thing is defined here using extern, which means it is defined elsewhere, and the linker says, hey, I can't find elsewhere. And so in fact, what happens here is that there's another file being created here for the server, which we need to add to our project. In fact, we can go ahead and open this in Explorer, see what's going on. So let's open that up in Explorer. So here goes. We have here this S file, that's the server file. So I actually have to add this thing to our project. This is where things are actually implemented by the RPC runtime, like the stubs that we need at the very least. So let's go ahead and add another existing item. It's a generated item, this S file. S stands for server. You can see it's a generated file, has lots of stuff. Some of it's actually very interesting. It shows how marshalling is actually happening there, but maybe we can look at that later on. For now, let's give it a shot and try to build it again. And we still get errors, but this time different errors. So that variable is now properly defined and we're good. But then we have a few functions that are missing, such as the add function. That's our own implementation. We have to implement this thing somehow. There are two other functions called user allocate and user free, with middle user allocate, with middle user free. This is basically saying that in order to allocate memory, whenever the stubs need any kind of memory, they want to call a function that we provide. So we have this flexibility, which I think is nice. Let's first fix that thing. So we have a middle user allocate. So we need to implement this function. Okay, so it's going to accept a size. And the simplest thing we can do is just go ahead and use malloc and make that allocation. And then the opposite thing is free, where we get a pointer, we need to free it. So I'm going to do the right thing and call the free function. Nothing to actually return, just go ahead and call the free function. So this gives you some flexibility as to how to allocate and manage memory. You can also intercept every allocation, which is nice. If we go ahead and build that now, then again, the only remaining external is our add function. Okay, great. So the add exists somewhere. Let's see if we can implement that. Let's go ahead and implement that in the simplest possible way. We can even add a little bit of printf here saying call add invoked with, just so we can see what is going on. And we're going to display A and B here to be nice to see. So let's see if we can build that. You can see that it doesn't seem to be working very well. We'll still have add as undefined. Okay, so let's find the function add. Let's start with the header file that we're supposed to be using, the one that we actually included. Let's go ahead and see what is the expectation here. So here's add. Apparently there's an additional parameter here called some kind of handle, which actually represents the connection with the client. And so we have to implement this kind of thing. So we're going to just go ahead and do that. There's actually a way to get around that, but for now we'll just stick it as it is needed here. So I'm going to add this handle T thingy. I'm just not going to do anything with it. I don't need to because it's just provided to the function by some infrastructure. And then finally we build and link successfully. So now we can try to run it. Let's see what happens if we run it. I'm going to press F5 to run this thing. You can see it says server process ID, which means it is listening successfully. What can we find about this thing? So let's go ahead and launch Process Explorer. So with Process Explorer, we expect to find maybe something or some kind of hint as to what is going on behind the scenes, because we're using a local communication entity here, using the local protocol. So let's find server.exe. And if we go to the list of handlers, you can see there's an ALPC port that has a suspiciously recognizable name like ncalc RPC and calc. That's exactly the name we provided to the endpoint. In fact, it's actually a kernel object here, of course, which provides this communication to the server. We can grab this thing if you wanted to. We can grab the address. Then I can go ahead and perhaps launch my local kernel debugger here. Here it goes. So here it goes. Let me just move that around. And I'm going to use the object command to show information about this ALPC port. So this is an ALPC port. Here's the address. We have that. And that's verifying this is an ALPC port. We can see the name as we expected. But now let's go ahead and use the ALPC command with the /p option and pass in that address of that ALPC port. And you notice that it says this is actually a normal, like a listening port. It's a connection port, and you can see the name. And we can see that server exe is indeed the owning process. That's the process object ID. And at this point, we can try to figure out what's going on, but apparently there's nothing very interesting is happening there. And that's of course understandable. What about the connections? And you can see there are 0 connections right now. Obviously this is correct because we have a server but no client just yet. So now we can go ahead and build out the client. So I'm going to, for now, stop this project, stop the server. Server will go away. We can build the client and then try to connect the two. So I'm going to create another console application just for the purpose of being a client. What we need to do here is to make sure that we're connecting to the server. We want to connect to that server and then send a request to add 2 numbers. Let's go ahead and do that. So the first thing we'll need is the definition that we've seen for the interface. So we're going to have to include the same file that was generated by the server. That's the header file that has all just declarations. There's no actual definition. There's no actual implementation there. It's just a server, just server definitions in terms of the interface. So we have the single function there called add. So now we're able to call add, and I can go ahead and try to call it. So I have to provide some handle, which I don't have just yet. Let's go ahead and try to build things from this perspective. Let's go ahead and try to add 3 and 5, and then if everything goes well, we can display that result like so. So that's all good and well, but of course we're not there yet. The next thing to do is to start building a binding. So we can build a binding in several ways. Here's one of them. I'm going to use again the same idea of some kind of status there and call the function RPC string binding compose. The idea here is that we can create a string that represents the full binding by composing a bunch of components which are parts that make up the entire string, the entire binding string, the entire information that we need. The first parameter is the object GUID. We don't need that because we have just the one. And then the protocol, of course, is going to be the same one. Of course, we have to match it. So again, it could be perhaps more useful to put it in some common header. In fact, we can put even that in the IDL file if we so desire, but probably less ideal because it limits our flexibility perhaps later. There's a network address here which doesn't need to be specified here because it's going to do things locally between two processes on the same machine, but I could have provided a network address here if that would make sense, if the server is in some other machine I'm aware of. And then we have the endpoint address, of course, and that's going to be again the same format that we provided on the server side of things, otherwise they couldn't really connect. And this allows us to have many services, of course, given different names. And then the next parameter is some options, which we don't really need. There's no special options that we need. And the result is going to be a string where the binding is going to land. So that's going to be RPC WSTR here. That's going to be our binding. It's a pointer to this string. Again, in order to make things slightly easier, we're going to define this constant RPC use native white character instead of coming up with their own types. So once we have that working for us, again, let's assume that everything is going to be fine. I'm just going to add an assert here just to verify. And then the next step is to create the actual binding handle based on that string. This is just a string, so it doesn't really do anything. We have to create the actual binding and get some kind of handle back. So we can call the function RPC binding from string binding. And we should be able to get an RPC binding handle from there. So the string, of course, we have. That's binding, thing we actually just built. And the handle, let's call that H for simplicity. It's going to be an RPC binding handle. That's going to be our H here, and we need to pass this H here, and hopefully that would do the deed. Let's see. So let's do that, and now we can go ahead and test it. Of course, there's a few cleanup things to do here, but I'm going to skip them for brevity, and we can try these things out. So the first thing I'm going to do, I'm going to go to the server. Well, in fact, let's see if it actually builds. Maybe I've been too optimistic. And in fact, I have been too optimistic. So the first thing to do, of course, is to get the RPC library into the project, because it's not a common library to use directly, so we need to add that. But then we still have an unresolved external for the add function. Makes sense, we're calling add here, but who is going to implement that add? So you might have noticed here that in fact there's a C file here, _C, which means that's for the client. So we need to get that thing to the client project. So let's go ahead and add an existing item here. That's going to be coming from the server. That's fine. It was just generated by the compilation of the IDL file. That's the client side of things. In the client side of things, we expect to find the add function here somewhere that does the right thing. Here's add, and this is the actual implementation, calling a function called ndr client call 3 and some information, which is going to be used for the actual transmission of the parameters to the server side of things. NDR is the network data representation format that is used by RPC. So now that we added that, we can try to build it. It still doesn't build because it still has the same requirements as on the server side, that is getting some functions to allocate and free memory. I'm just going to do a little copy paste here. Using malloc in this little example is perfectly fine. Okay, let's try it again. So now it builds. I guess that's something. Let's see if it actually works as expected. So the first thing I'm going to do is to set a breakpoint here in the server, so we can in fact Little hiccup here because pressing F10 stops the recording, so I'm not going to press F10. I have to change that later. Anyway, we have A and B with the correct values. We can continue execution, and we'll see that the server has written that information to the console, and the client application is basically done. So we're out. The client just displayed this result and just went away. We can press Ctrl F5 to run it again. Maybe use the client here with debug, start without debugging, and we'll be able to see, again, we have the breakpoint, of course. Let me remove that breakpoint, press F5 to continue, and now we have the correct result from the client. And so, of course, we can look a bit deeper and customize this in various ways, but I think it should be good enough for a simple RPC demonstration. Feel free to look in the debugger, so which things are connected to the process. In fact, let's try it just one more time. Let's go ahead and run another instance of the client. Okay, so we're in the breakpoint. Let's go ahead and find our server again. Here's our LPC port. Let's grab the address. That's a different address, not the same address anymore. Going back here, let's go ahead and look at that. So you can see there's one message in the queue. Pretty easy to see that, and you can even get information about the message, an LPC request. This is kind of a standard message of sorts. You can see there's lots of other details. Here's a list of connections. We can see the connections shown right here. We have the client exe, which is the one that is being connected to the server right now. And so with that, we can see that indeed we can do simple RPC. Feel free to play around with these things as you see fit.